Good morning. Today's topic is armature reaction. The definition of armature reaction is action of armature flux on main flux is called armature reaction. In a DC motor or generator, there are mainly two parts. One is field, another is armature. Suppose this is field. This is N and this is S. The flux is going from N to S. This is the field flux. And there is a two type of axis mainly. This is D axis and this is Q axis. So main flux are going from N to S. So this phasor is phi m. There is a no armature, only field flux are present. If there is armature, this is armature and this is the brass. Suppose no field flux is going. So armature, this is armature conductor. This is suppose we taking this is a cross component and this is a dot component. Cross and dot. Cross significance, the currents comes in. Cross significance, currents come in, and dot significance, currents comes out. According to Cross-two rules, if current comes in, suppose current comes in, then the flux is this direction, and suppose current comes out, flux is this direction. So suppose in this here, this is a dot and this is a cross. Cross means current comes in, go outward, and flux is this direction. So flux direction is this. If current is comes out, then flux direction is this. So current comes out, so flux direction is this. So this is the flux direction. So in this case, this is the flux direction. All are downwards, and also same. This is also in downwards. So the armature flux phi A are downward direction. If we add two phasor in a one phasor, then we get the suppose this N to S, this is armature, the flux is going through that direction, and suppose this is a dot and cross. Suppose this is we taking cross, this is a dot, so flux is downward direction. So for the phasor, very important phasor, this is phi m, this is phi a, this is d axis or geometrically neutral axis. The resultant flux is phi r. The resultant flux is phi r. If armature current is less, then phi r, suppose armature current is this, so resultant flux is this direction, and when the armature current is more, then flux distorted more. When the armature current is less, then flux distorted less. So this is the basic phasor of armature reaction. Now this is a brass. This is a brass. Brass is always present in magnetic neutral axis. Brass is always present in magnetic neutral axis. So in this phasor, magnetic neutral axis and geometrical neutral axis are same line. Magnetic neutral axis. But very key point, magnetic neutral axis always perpendicular to the resultant flux. the magnetic neutral axis is always perpendicular to a resultant flux. Suppose we take the resultant flux phi r, then magnetic neutral axis shifted to this position. If I draw here, suppose this is phi m, this is phi a, this is geometrically neutral axis or d axis, this is phi r, this is m n a. M n a shifted g n a by theta degree. So in the brass is present in M n a. So brass also shifted. So diagram will like that. Clear? Now the flux direction. When there is a no armature current, then flux direction is this. Suppose there is a armature current and flux direction, we can plot the flux direction. This is new MNA. This is suppose taking cross. This is dot. Very interestingly, N2S are going this way, and the flux is going this way, and this flux also going this way. So if we notice in that position, this flux is coming that way, the flux is coming that way, and there is a flux in the flux also going through this way, and in this position flux is coming that way and this flux is that way. So resultant flux is more here and less here because this nullify that. Similarly, flux is coming into S, the flux is coming here, and in this position flux is direction is that way, this flux. So this flux is nullified and this flux is additive. So total resultant flux is this way. This is a total resultant flux. Into S the resultant flux is this way. So this, though, if when there is a no armature current, the flux direction is this. When there is an armature current, the flux direction is that way. So armature current or armature flux distorted the main flux. That means field flux is called armature reaction. Armature flux, due to armature flux, when there is no armature flux, field direction of field flux is this way, and there when there is armature flux, the direction of field flux is this way. So armature flux distorted the main flux. Armature flux distorted the main flux is called armature reaction. And due to armature reaction, there is a two types of phenomenon are there. One is demagnetizing, another is cross magnetizing. Due to demagnetizing, EMF is reduced in case of generator, or torque is reduced due to motor. This is a phenomenon of demagnetizing. And due to cross magnetizing, the spark happened in the brass. This is the brass, this is the brass. Spark happened in brass. Sparking happened in brass. So this is armature reaction. Suppose there is some mathematics also there. For that mathematics, some formulas needed. The formula is, first of all, we have to know what is mechanical degree and electrical degree. Mechanical degree and electrical degree. Suppose this is a two-pole motor or generator. This is N and this is S. The mechanical degree N to S is 180 degree. And electrical degree also N to S is 180 degree. But suppose this is a four-pole motor. The mechanical degree N to S is 90 degree, but electrical degree always 180 degree. N to S electrical degree always 180 degree. So the formula of mechanical degree theta m is equal to theta e 2 theta e by number of pole. 2 theta e by number of pole. This is a very important formula. Mechanical degree is equal to 2 into electrical degree by pole. And sometime we can get, sometimes the numericals are based on demagnetizing ampere turns per pole and cross magnetizing ampere turns per pole. That is ATD, that is demagnetizing ampere turns, AT ampere turns demagnetizing per pole is equal to theta m, that is mechanical degree, by 360 into Z into I, where Z is the number of armature conductor, Z is the number of armature conductor, and I is the current in each armature conductor, current in each armature conductor. So our current is in each armature conductor. So I is equal to IA by 2 in case of wave winding, and similarly IA by P in case of lap winding. So we can get the ampere turns demagnetizing per pole. Another is ampere turns demagnetizing, cross magnetizing per pole, that is ATC by pole is equal to Z into I 1 by 2p minus theta m by 360. So this is where Z is also total number of armature conductor, I is the current in each armature conductor. So in this formula we can get the armature ampere turns demagnetizing per pole, ampere turns cross magnetizing per pole, and suppose this is the theta m, the mechanical degree is equal to 2 into electrical degree by number of poles. This is number of poles. Okay, that's all.